Okay, so picking up some more midterm review solutions. All right, which method of proof may be used? Okay, so RS is the same as ST. SR is perpendicular to QR. ST is perpendicular to QT. Okay, the only one you're going to have to come up with this on your own, the reflexive side. Um, so, side-side angle is not an option. The reason it's side-side angle is because if you look at um, one of the triangles, it's two pairs of sides, but not the included angle. Okay, it would have to be this angle to be the included angle. But side-side angle is not one of our 5 methods of proof that are proved. Okay, it'll get it down to 2, but that's not good enough. All right, here's a unique situation, though. Because it's a right triangle, right angle there, what we end up having is this is the hypotenuse, and this is one of the legs. Okay, so what we have is, since it's a right triangle, we have hypotenuse leg as an option. So that's what this one is. Okay, so that's 24. All right, okay, so this is interesting. The line x equals 0 has stumped a few of us on past tests, quizzes, things like that. The line x equals 0 is not the x-axis. It's actually the y-axis. X equals a number. Those are vertical lines. Okay? So x equals 0 is actually this one. Uh, every point on the line has an x value of 0 if you go anywhere on that. So that's why that's the equation that describes that line. Okay, so it makes sense. So we'll start graphing 1, 1, 3, 2, and 1, 6. All right, so there's A prime, right? You want to move perpendicular in the same distance away. Moves perpendicular, same distance away from the mirror. Same thing. Okay. All right. Now, let's see. There must be more. No, that's it. Okay. Are there any invariant points? No. None of the points on the pre-image were on the line of reflection. And that's what has to happen to have any invariant points. Basically, all the points moved. Moved. So, it doesn't always happen. Is orientation preserved? No. A line reflection always switches orientation. Okay, so that's it. You could look at it. Here's the orientation. I spoke of it earlier. It's really critical that we consider that. Okay, so A to B to C, that is in a counterclockwise arrangement, which is its orientation. A prime to B prime to C prime. If you circle it, start at A prime move, that is going with the clock. Okay, so that's different orientations. But we knew that. So, good enough. Okay, great. This is from the last chapter. Critical that we go over this. Um, chapter 5, relationships and triangles. Okay, so these are all midpoints. So we have what we have is all mid segments. All right, really important that we talk about this right now. So if we hit all the midpoints, it's going to look like this as far as the marking goes. Some interesting stuff's going to happen here. Let's just say for a minute that this were, I don't know, 10. what you should know is then that's 20 or 10 each. Let's say this one's 7, and that's 14 altogether, or 7 each. You can see the relationship here. Okay, those are the same, and that's going to be the same as it. Okay, this is a triple, triple, and that's triple. Let's say this is 8, you know, just for, whoops, just keep that going. Okay, then this whole thing 16, or they're 8 each. So that relationship's really important to understand. Now if we go to this one here, UW is 4x minus 1, right? And the whole thing, YZ, is 5x plus 4. What I like to show students is the relationship between this one is the same. This mid-segment is the same as each half. So really, this is a 4x minus 1, and so is that, believe it or not. So what you could do is, this 5x plus 4 is the same as 2 of those 4x minus 1s. You know, there's a few ways to do that. So I'm just going to combine like terms over on this side and start solving. I like to get the x's to one side. I usually move the smaller one, but to try to avoid dealing with negatives. So 3x equals 6. Whoops, sorry, I'm going ahead of myself. Divide by 3, and x equals 2. And what is the length of UW? So you have to plug back in. So 4x minus 1, so 4 times 2 minus 1 equals 7. UW equals 7. All right, keep going. Let's see. Okay, two vertices of a right triangle are 6, 1, 3, 4, 5, 6, 1, and negative 2. Okay, now, if it's a right triangle, the easiest would be to throw a right angle there, okay, or there. But they restricted us. They said its y value was negative 3. So it's somewhere along this line here. So that's no fun. Okay, we're gonna have to do something else. On the graph, if you want a right triangle, and you know your sides are gonna be, you know, possibly tilted, which AB is, by the way, right? What we're gonna have to do is we're gonna have to make slopes negative reciprocals. That's how we're gonna get our right angle. So there's also another difficult part of this problem potentially, which I'll have to investigate. Yeah, it's not going to happen, but I'll show you that on Geometry Sketchpad just to explain. What we're going to do is we do just need slopes to be negative reciprocals. So what we're going to do first is we're going to get AB's slope. Okay, we don't get distance, we get slope in this problem. Okay, so I'm going to complete this 1, 2, 3, 4. Just double checking that 4 and 8. Look, something isn't right there. Yeah, that is good. 4 and 8. Okay, so the run is 8, the rise is 4, and it's heading down, so it's negative. I'm going to take out a 4. So really the slope is negative 1/2. Okay, a perpendicular segment needs to have a slope that's equal to 2 or 1, right? We took the negative reciprocal. We flipped. Reciprocal is flip, and the negative is change the sign. So negative reciprocal slope. All right, now here's what I can do. I can apply this slope to either A or B. So let's apply this slope with A first. Okay, what I want to do is go down to, well, actually I want to go up to right 1, but I'm not going to run into the line that way. Right up to right 1 is going to take me this way. I want to go down to left 1. Okay, this is one possibility for C. All right, I could do that from B down to right, left 1. I could have another possibility for C. You could pick either one. So let's go ahead. I'm going to pick the closer one. I'm going to use this one. Okay, that's going to be my triangle. All right, that's 1, 2, 3, 4. Yeah, 1, 2, 3, 4. So my C is at 4, -3, so A is 4. Now, explain why your choice makes it right triangle. Okay, so first, the slopes of AB and AC are negative reciprocals. So AB is perpendicular to AC, and angle A is a right angle. Now, because perpendicular segments form right angles, okay, finally, now triangle ABC is a right triangle because it has a right angle. All right, that's it for this video, and there's more to come on the next ones.